All right. Yeah, I request everybody again to switch on your videos. All right. So basically what happens here is a beam is subjected to forces which are perpendicular to the axis of the beam. If you notice, the force is perpendicular to the axis of the beam. So there can be different types of loads. This is a point load where the point load is acting at a point. This is uniformly distributed load, and this is a uniformly bearing load. Okay, so this is known as a beam. So some examples of a beam, most of you know in constructions, in your classrooms, everywhere, in buildings, you have a beam. It supports the weight. Okay, axle of a car is one of the main examples for a mechanical engineering, and any type of shaft of a machinery is a beam. Okay, and so this is the static equilibrium equations that we have seen before. What is static equations of equilibrium? That means forces in x direction, summation of all the forces in x direction equal to 0. We drew free body diagram. I hope you all remember. We learned about free body diagram last week. Okay, and we solved some of the unknown forces using equilibrium equations. Okay, so these are the equilibrium equations that are available. That is sigma fx equal to 0, sigma fy equal to 0, sigma fz equal to 0. Then moments in all the three directions, summation of that equal to 0. Okay, so this is what we're going to use to find the support reactions as well. So force in all the x directions, that means all the horizontal forces, add them together will be equal to 0. All the vertical forces, add them together, all the forces acting in z direction equal to 0. Okay, so that is known as a equations of static equilibrium. All right, now you need to understand what is a statistically determinate system. Okay, so if the equations of statics, that is all the equilibrium equations, okay, uh, is enough to calculate any external load or internal reaction, it is called as statically determinate. I hope you're able to understand. Okay, if this equations of statics, you have already solved some problems based on it. Okay, still people, you've not switched on your video, please, I'm asking you guys to please switch it on. All right, so you have the equations. Last time when we did a free body problem, okay, we had two unknowns and two equations. Okay, and we have to solve these two equations to find the two unknowns. What if there are three unknowns and only two equations? Then how will you solve the problem? You cannot solve the problem. You just can't. Okay, it has to be equal number or more. So if the equations of statics suffice for determining the external reaction and internal stress, then the structural system, the beam, is said to be statically determinate. If it could not be determined, then it is known as statically indeterminate system. Deter, okay, there's a mistake here. R should be there. Understood? Okay, so now write the heading as you have learned. I want you guys to write points. What are the points that we saw till now? Beam. Okay, I will also write the heading as supports. And then the first point you learned is what is a beam. Second point you learned was equations of, I'll go to that slide. Yeah, equations of static equilibrium. Please write it down because this is what we're going to use. So you can write down all the six equations. Switch on your videos, guys. 1, 2, 3, 4, 5. Only 5 students out of 33 have joined. No, 6 students. Febin has just now switched on. Sam, don't switch it off, okay? Keep it on. Only 7 students have switched on out of 33, not even 50%. What happened to the rest? Thanks to Calvin. Calvin has switched on. Finished? Okay, and the third point you learned is statically determinate system. Write that down. Just one point. Statically determinate system. Rachin, you came and went. Now it's back. It's working. Ashwin, Alan, Alex. Okay, finished? The next topic that we're going to learn is type of supports. Okay. So this is important. Write the heading as type of supports. Okay. So the first one is known as the roller or link support. Okay. So let's see what is a roller or a link support. So you can just draw. So if you notice here, it's a roller. All right. So this is the roller here, and this is the beam which is attached. It can be placed inclined. It can be horizontal, like this or like this. Okay. So in this, we are resisting force only in one specific direction. That means in this direction, force is being resisted. Okay, but in this direction, it is not. In this, it can roll. Horizontal direction, it can roll. So, if you want to denote this, how many reaction forces will be there? Only one reaction force will be there. Okay, and that reaction force will be opposite to the, it will be here at the support. Over here, the reaction force will be there, and there will be only one. That is only the vertical force. So did you understand? Simple. It's a roller support. In horizontal direction, it can move. Vertical direction, it is restricted. So whichever direction the movement is restricted, that means there is a support. Okay, and because of that support, there will be a reaction force. Last time, Siol, where are you? I think someone else came to his room or he's outside. Okay, never mind. All right, so did you understand? So because of a support, there will be a force acting towards the body. Last time we saw how do you write a reaction force, and for a link, like for a rope, it will be a tension force away from the body, but a reaction force to the wall or reaction force on from the ground will be towards the body. Okay, so that's why if you see in the slide, it is towards the body, and there's no reaction force in horizontal side because it is moving. It's not restricted. Okay, understood? Can we go to the next support? If you understand this, half your so these are some of the examples of a roller support. It's a roller support. Here also it's a roller support. Okay. Next is hinge support. So all of you can write point number B, hinge support. That means in both the direction it is restricted. Okay, the movement of the beam is restricted. So it is denoted by a triangle and then this thing, point A. So in the vertical direction, there will be a reaction. That's why it's given as RAY. And horizontal direction, there is again a reaction. So AX, we are naming it. Okay, so it is known as a hinge, or it is also known as a pin support, a door moving. Okay, it's a pin support, restricted in any direction it is of the plane, it is restricted. Got it? Okay, you just have to draw the diagram. Anthony, did you finish writing? Anthony, you're not there in class? Or you generally have network issues. Jason? Done?
Yes, ma'am.
Okay. Next is fixed support. Ask Seol to give me a call after class. Who is Seol's friend? Today, this person is not there. Christian is not there, right? Did not join. Okay. Okay, anyway. So fixed support is the next one where it is completely fixed. Okay. Able to resist a force in any direction and also able to resist moment. Okay, it is also able to resist bending moment. All right, so you have a cantilever beam and a force on the edge here. So there will be a reaction force. All the forces in all directions are restricted. So you have a reaction force here, FV, and a reaction force FH, and also a moment or a couple. Okay, so for a fixed support, you will have reaction FV, FH, and a moment. So that's a fixed support. Did you understand? So what was the first one? Roller support, hinge support, and fixed support. Roller support will have only one reaction force, vertical. Okay, and hinge support will have two reaction forces, vertical and horizontal, towards the body. And the last one is a fixed support where you'll have two reaction forces and a moment. Is that clear? Okay, so let's go to the types of beams. Okay, now just write the heading as, so this is your 5th point that we learned today. Okay, types of beams. Okay, so first one is a cantilever beam. Let's see that directly. So you know what a cantilever beam is. Just draw the diagram. You have a fixed support and then it is free on the other end. Okay, you have a fixed support and then you have a free end. Next is propped cantilever beam. Okay, one end is fixed and the other end is supported. Propped cantilever beam. All right, you have one end fixed and the other end is supported. All right, then you have something called the freely supported or simply supported beam. So if you notice here, one side it is hinge support and the other side it is roller support. And you have a load. Both the sides also can be hinge support. All right. I hope you guys are writing. I'm also writing, so I know how much time I have to give you. Just write the name and draw the diagram. That's it. Can I go to the next one? Done? Good. Okay, next is overhanging beam. So if you notice here, they have it's like a simply supported, but it overhangs. It can overhang from the left, right, or left, okay, or on both the sides. So write the heading as overhanging beam and draw the 3 diagrams. Rohit, done. Richin, over. Sam is completed. Mukesh is also done. See, when your videos are on, it's so much easier for me to monitor. See, all is outside. Looks like even the rest of the others. Harsh, are you there? Mohammed, where is Mohammed? Mohammed says he's done. Yeah, at least if your video is off, at least you guys can respond in chat so that I'll know that you guys are there. Okay. And the last one is fixed beam, where it is fixed on both the ends. After this, I'm going to teach you something which is very important. Next week, we will solve problems on it after exams probably. Okay, but just learn the concept. Done, guys? Okay. Now, you have understood what are the different types of beams, what are the different types of supports, and for each support, what kind of reaction forces will you get. Okay, so, oh, this we forgot. Okay, please write down this. Types of loads. I'm going fast in this because you guys must have learned all this in your lower classes. Have you done this before in physics? First one is concentrated load. So what is a concentrated load or a point load? So concentrated load is, for example, you have any time. I've not given any. Okay. Concentrated load is at a point, acting at a point. Okay. So I'm just going to draw a simple, you guys don't draw. I'll show you my iPad and then we'll do it. Just write the heading. Okay. Concentrated load is a point load. For example, you see two columns in a building when you enter a building. Okay. And there will be two columns or a house in the car shed. Okay, there will be two columns. So that two columns is actually, because the area is so big, the floor, you know, that those two columns will act as a point load. Whereas the complete house in that area will act as a uniformly distributed load. Let me give you another, okay, I should draw and show you. Anyway, we'll, then you write down the next point. This is the sixth point, okay? Point number A and sixth point is point load. And then you have uniformly distributed load. Please write the point down, uniformly. I will explain it later, okay? Distributed load. So if you see this diagram, there is a beam, okay? And this, throughout this beam, there is a weight. And there are some goods over here, okay? Sacks of rice or something, whatever. All right. And so this is the weight of the beam. It is denoted like this. It's a uniformly distributed load throughout the beam. The beam weight alone. Okay. And on only in this area you have some extra load. And it's also a uniformly distributed load. Okay. And the last one is known as uniformly varying load. Uniformly varying load. Clear? Okay, so couples and forces we have already finished. Yeah, that's it. Okay, so now I will stop sharing and share my screen. So I told you, are you able to see my screen? Yeah, so this is a point load. A uniformly distributed load. For example, I have a beam. Okay, uniformly distributed load. So I have a beam here. It's a simply supported beam. And if I want to show the weight of the building, I will show it like this. Okay, but on top of the terrace, only in this part, there is the water tank. So the water tank also has a large area and it has weight. So this also can be denoted in this way. All right, weight of the beam plus there is an extra weight of the tank. So if this is your beam, you will denote it like this: weight of the building and weight of the water tank. It's a uniformly distributed load. And similarly, you have the varying load, uniformly varying load. So that means you have the, for example, let me take an example of a dam. Okay, the dam wall is like this. Okay, it will always be in a slanted this thing. Okay, I'll draw it here. So if you take a dam, the dam wall will always be in this way. Okay, so the water is over here. So you'll have a force, correct? You will have a force. So the force acting on this wall, the deeper it goes, the force will increase. Are you getting me? The deeper you go, the force on the wall, as well as at the bottom, the force will increase. That's why you always have a dam wall which is slanted. Why? Because it should withstand that much load. Okay, so that's a hydrostatic law. The lower you go in a sea level, the pressure is higher down compared to the top portions. All right, so it's a varying load. So how do you denote a varying load on a beam? So you have a beam. Let's take a beam here, and if I want to denote a varying load, it will be like this, a slant line. It's a varying load. Got it? Any doubts? Any doubts still here, guys? So we have, so what all did we learn today? You learned about supports, beams. You learned about supports, beams, okay? Static equilibrium. What is a beam? Statically determinate system. Okay, types of supports, roller, hinge, and fixed. Okay, and what type of reaction force comes in for each of the supports. Types of beams. All right, cantilever, simply supported, overhanging. So there is cantilever here, propped cantilever, simply supported, overhanging, fixed. Then types of loads, concentrated load, uniformly distributed load, uniformly varying load. Are you guys clear till here? Any doubts? Clear? Okay. So now, let's take a cantilever beam. Okay. One second. All right. Let's take a cantilever beam. All of you can draw. Write the heading as reaction forces. Okay. So I'm just going to take for one beam and do it for the day. So you have load. I'm going to name it as A, B. Okay. And the length here is given as L. You guys are clear? We have a cantilever beam. There is a point load at the end. Okay. There is a point load here. And this is a fixed support. So can you tell me, first step is to draw the reaction forces. What are the different reaction forces that will be acting over here? You'll have a vertical force. Yes. So R, A, Y. You will have a horizontal reaction force. R, A, X. Correct? and you will also have a moment at A. Why am I drawing the moment in anti-clockwise direction? You have a fixed support on A and you have a load. Will there be a moment which will be created here? Yes, W into L. There will be a moment. Okay, there will be a moment which will be created. So there will be an equal and opposite moment. So this moment is downward clockwise direction and WL. Are you getting my point? Okay, so now what are the forces and the moments acting on a cantilever beam which has a fixed support and a point load at the end? And this is W. Okay, the value of point load is W. So you have W and a moment WL, and you have a reaction force RAY and a reaction force RAX. Okay, and a reaction moment. Now use your equations of equilibrium. That means Fx equal to 0, Fy equal to 0. There is no Fz, so I'm going to leave that. Moment in x direction equal to 0. Okay, clear? Okay, Fx. So you have only Ra in positive direction equal to 0. So we are assuming that the system is at equilibrium. What about Fy? What are the vertical forces you have? Ray, positive upward direction, minus W equal to 0. So what is the value of Ray? Equal to W. So this is your first reaction force that you have found out. This is the second reaction force that you have found. What is left? You need to find the value of MA. So what is this? Moment with respect to any point. What is sigma mx equal to 0 means? In that, there's only one dimension, right? There's only one dimension here. So moment with respect to any point is equal to 0. So I'm going to take moment with respect to A. Okay, so let's calculate the moment with respect to A. How many forces are there? You have Rax. It passes through the point, so 0. And then you've got Ray multiplied by 0. Then you have this WL, which is minus WL, clockwise direction, right? So minus WL, and you have an anti-clockwise MA equal to 0. Clear? Okay. So finally you have MA is equal to WL. So this is your MA. Are you following me? Did you understand? The sign conventions that we are using is same. Upward force, downward force negative, right side positive, negative. Anti-clockwise is positive and clockwise is negative. So because of this moment, there is an equal and opposite moment, MA, at point A. Okay, because of W, there is a equal opposite vertical force, reaction force. And because this is a fixed support, there will be a horizontal force, and there is no external horizontal force, so the horizontal reaction force will be equal to 0. Understood? Clear? Any doubts? Everybody wrote it down? Finished? I think we don't have time for the rest, so I'll close for today. Yeah, there's a chat box. Yeah, thank you for responding. So what I will do now is, see, we have to learn for a uniformly distributed on cantilever beam. And then we will go ahead for a simply supported beam with hinge support and roller support. Okay, and simply supported beam with point load and uniformly distributed load. So till now we've just learned the basics, and I have told you I've just done one problem on how to calculate reaction forces. Okay, so basically we use the equations of equilibrium. So whatever I've taught till now will be coming for your exam. Is that clear, everyone? Yeah?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
if you have any doubts, you can please reach out to me and ask me your doubts. All right. So from the beginning, we have learned what is a force, what is statics, what is dynamic. Okay. I have shared PPTs already on the Google Classroom. This PPT also I will upload it. Okay. It's 1 mark question. So I will upload the question tomorrow. It will be open till Saturday. For 1 day, it will be open. I'll it, so you'll have enough time for you. Can you hear me? Yeah, you will have enough time for preparation. So tomorrow, Friday evening, I will, anyway, it's a holiday, correct? So evening 5 o'clock, I'll open it and it'll close by Saturday 5. Anytime you're free, you can take the test. Okay? So if you have any doubts, you can please feel free to contact me. Sunday morning I'll not be available, but Sunday evening I'll be available to clear your doubts. Okay. So all the best. Do well.
Ma'am, due
Yeah,
time,
Harsh.
with the time, which time?
I didn't understand. You're not audible.
टेस्ट टाइमिंग ड्यू मतलब आपने टाइम क्या कहा मतलब कहाँ से कब तक टेस्ट दे सकते
Friday
हैं
5
टाइम?
बजे से Saturday 5 o'clock.
ओके ओके थैंक यू
हाँ.
वही पूछना था.
Okay, clear? Nathaniel, what happened? You joined the class half an hour late.
No, actually, I tried joining at 12, but network was.
Oh, okay.
I was not able to join.
Okay, no problem. It's recorded. I will share the recording.
Sure.
All right. So thank you all for joining in. You have any doubts, please get in touch with me. Okay. All right. All the best.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you, ma'am.